Our focus this chapter, mainly, can you find the zeros of a polynomial? That's the biggest thing. Can you solve a polynomial equation? Okay, so that can come in the form of factoring, or the quadratic formula, or completing square, or graphing, different methods, many of which you've already learned. We'll learn a little bit more, and we'll practice what you already know. Okay, so a polynomial, just keep in mind, here's an example of a polynomial. So we're studying any polynomial. Yep. So our parent function knowledge will come into play pretty big here at times. So, let me write one. Okay. A few terms. Hopefully you already know these. If you don't, this is called here. What? Coefficient. Yeah. In fact, this is the leading coefficient because it's with the highest exponent. Okay, so that's a leading coefficient. The rest of these would just be coefficients. I do not know where that word came from, but that's what we use. What degree is that polynomial? What? The degree 3? The highest exponent? Okay. Does not always have to be the first exponent in the list, but it has to be the highest number. Okay. So that's the degree of a polynomial. It does give us some really handy information. Keep in mind, this is called a constant. It gives us some information about that polynomial, the y-intercept. So this will always be the y-intercept. Okay, so a few words. Questions? Okay. So polynomials will cover the spectrum of our parent functions as well. Okay, so remember those graphs. But one of the key things that we look at are x-intercepts. What is do you know the highest number of possible x-intercepts that would have? Have you ever analyzed that before? Okay, so a degree 3 polynomial can look like this. How many x-intercepts? 1. Okay, so 1 is a possibility.
But it could also be 2.
How could it have 2?
If you just move it down a little bit to where the relative min touches the x-intercept.
Yeah, if this were touching the x-axis, we could do something like this. 1, 2, x-intercepts. Okay. Do we have 3?
Yeah.
Okay. Can you produce a graph that has any more than 3?
No.
It's impossible? You sure? I agree. Okay. So a degree 3 polynomial has up to 3 real number x-intercepts. Okay. And it has to have at least 1, right? So every polynomial follows that rule. So this is a degree 3. It has up to 3 roots, zeros, or x-intercepts. If I gave you, so graphically, these are called x-intercepts, right? We have other words for them. So if I give you a function, if you found the x-intercepts of the graph, but the function would say, find the zeros. So that's another way we can word that same problem. Right, so graphically, they're x-intercepts. In function form, we have zeros. And then if you have an equation, you'd say find the roots. Okay. So any one of those 3 words should clue you in to the same thing. Right? It just has to deal with the type of equation, function, or graph that you're looking at. But they're all asking the same question. For any one function, every one of those will give you the same answers. That's it. Okay. Good? Pretty exciting stuff, isn't it? Yeah, not really. Definitions and base work in math is always a little bit exciting. All right, let's consider so you'll be asked about leading coefficients and degrees and coefficients and such. Okay. Do you want me to put that on there? You think you can handle it? You can handle it? You want to put it up there? Okay. So a question you could be asked is, what is the degree of f of x? Okay, 3, right? Okay, what is the leading coefficient? Okay, coefficient, always a number. So, 1. So those are questions that can be asked based on the vocabulary. another one. Is 4 a 0 of f of x? That's easier than that. You could do that. Makes it more difficult. Yeah, so all you have to do is evaluate. So f at 4. What do we want that to equal?
0.
Right, 0. So if you evaluate f at 4 and it gives you 0, you have a 0. Okay. We'll get to synthetic division. So we would have 4 cubed minus 6. Pretty sure that works. You can answer yes. It does. Yeah. It's right here in the book. I'm just. Yeah, you know, I mean, that's pretty basic. Do you remember what complex numbers are? So part of polynomials, so if we were in this black situation with the black graph, there's one real x-intercept, correct? If you did the math algebraically, this would actually give you two complex zeros. Okay, if they don't show up on the real number graph. Okay, so there's always three. It's just a matter of how many of them are actually real. Okay. For calculus terms, we only deal with real numbers. Okay. In the calculus you will learn in high school. There's something called complex analysis, which deals with calculus of the imaginary numbers. But, yeah, that was a fun class. So this would have one real and two complex x-intercepts. Okay. So a complex number is a real number plus an imaginary. So like 3 plus 2i. Do you remember what I equals?
Yeah.
Or I squared is?
I squared is -1. I cubed is negative I to the fourth is 1. And then I to the fifth is 1.
Okay, so I squared of -1, I squared is -1.
Isn't it? I fourth is just 1. I do 2.
Yep. So yeah, you can do all sorts of exponent manipulation of that, right? Here's is really interesting. Electrical and mechanical engineers have to deal with those. Okay. So electricity has complex numbers in it for some reason. So does heat transfer. Okay, so there's some engineering applications where you actually have to use complex numbers. Okay. So they are useful. They aren't just a fun mathematics thing. Okay. They are useful. Right. So can you write a polynomial with roots kind of backwards the way you've probably done it in the past. So let me take a step back here. You're given a polynomial. And ask for the roots of that equation. Remember how to factor? No, it doesn't. It's very handy. It actually makes things easier. Can you factor that into two binomials? Remember, multiply to get 6, adds to get 5. Yeah, the only possibilities. Okay. Oh, that brings back some numbers. Doesn't it? Help you up. What are the roots of that equation then? Right, these are the roots. Okay. So, if I give you the roots and you work backwards, that's what this problem is. Right? So I gave you the roots, can you make a polynomial? So we're going to start here. Okay, so what's the first binomial? X. What? Plus 2 or minus 2? It's got to make this 0. Minus 2. Because if you plug 2 in, 2 minus 2 is 0. Okay. So it's always going to be the opposite sign. What's the next one? Minus 4i. And then plus 4i from that one. So you've just written a polynomial. Sweet. So good. Happy Halloween. Okay. So you've just written a polynomial of degree 3. Okay. Can you finish this to simplify it and make it a polynomial such as that? Okay, so how do you put these two together? Remember the acronym?
Of course I don't.
FOIL?
You never learned.
Yeah.
What? By who?
Yeah.
Okay, that's done. Alright, so you are going to multiply these together using this acronym, right? So the first times the first, x squared. Okay, how about the outers? Plus 4ix. Inners. Minus 4ix. And then your last one, right? 4i and negative 4i. What does that make? Minus 16i squared. Okay. You following?
You're just going fast.
Somewhat. Am I going fast? Too
Yeah.
fast? I could slow down. No problem. They are eyes. What?
So you cancel out before I X.
You can, yep.
And 16, I.
Are we good with FOIL?
Don't move it yet.
I'm not moving it, I'm just asking, are we good?
Because you moved so fast.
Just waiting on them. We'll see if people are not as fast, which is okay. Alright, so we're good with FOIL? Jerry? Are you okay with this?
Yeah.
Okay then. What's the next step? Okay, you might want to get a clue. Combine like terms. This is 0, right? They cancel each other out. And then what is negative 16i squared? Remember, I squared is negative 1, right? So plus 16.
Oh, this is like.
What's your next step? So we combine the like terms, since we're right there. What do I do with that? I need to finish it. I need to get it in polynomial form. You still got two binomials. How do you combine two binomials? Multiply. You put them together again with FOIL. Right, so first outer, inner, last. And then it is convention for us to write it with the exponents in order. That's just not absolutely necessary, but it does help in certain circumstances, and it is prettier. As I think we need to go today. There are some problems in this section that deal with you having to factor and solve algebraic equations. We will get to that. Right? But not yet. Here we go. So there is the practice. Should be pretty straightforward. Oh, I did. Whoops. Okay, we're just starting chapter 5 in BC Calculus. 4.1. My apologies. I got to do something, right? And there's the work. We will be moving into factoring starting tomorrow with quadratics, so bring your melons.